We all know salmon for the delicious food they provide, like sashimi, smoked salmon, to even salmon burgers. But what many don't know is how truly phenomenal these fish are. Today, I want to take you guys with me through a salmon's life, visiting spots along their trek within the Great Pacific Northwest, while I explain what I think to be one of the salmon's most impressive skills, being able to thrive in both freshwater and saltwater environments. Salmon are known to be anadromous creatures, which means their young are born in freshwater lakes and streams, but migrate for saltwater later in their lives. Salmon can migrate from freshwater to saltwater thanks to a process called osmoregulation. Osmoregulation is crucial in regulating the balance of water and solutes within cells and tissues. This regulation is obtained through osmosis within the cell, which is the diffusion or moving of water molecules across the cell membrane, moving from low solute concentration, which is high water concentration, to high solute concentration, which is low water concentration. For salmon to make these changes, first the young salmon must smolt, consisting processes like gill remodeling, kidney changes, hormonal shifts, and intestinal changes that allow them to drink seawater. After smolting, the salmon proceeds to drink lots of water around it. This is because when the salmon is in salt water, the salt concentration around them is much higher in the water than in their bodies, causing water in their cells to perform osmosis and leave their bodies. To avoid dehydration from water molecules leaving their cells, salmon must consume lots of water to make up for it. Second, to avoid dehydration once again, salmon must drop the urine production in its kidneys, expelling smaller amounts of water. Third, salmon gill cells have an adenosine triphosphatase molecular pump, which was discovered by scientist Jen Sisko in 1957 and is more commonly known as the sodium-potassium pump. The sodium-potassium pump is found inside the plasma membrane of the salmon's gills. It has the function of pumping 3 sodium ions out and 2 potassium ions in, with the usage of ATP and other transporters. This pump is used to maintain ion gradients, which is crucial for cell function. While in freshwater, salmon gill cells absorb ions from the environment using ion exchangers and channels. But when the salmon goes into salt water, it must expel the excess sodium that salmon consume as a result of drinking large amounts of the salt water. This is to ensure that osmosis does not lead to dehydration in the cells of the salmon. The salmon gill cells with the sodium-potassium pump become active. Once active, the pump will perform its function and pump out sodium from out of its cells and take in potassium. In this way, salmon adapt to live from freshwater to saltwater. This process is then reversed when the salmon come from the oceans back to the rivers and lakes to lay their eggs.